A couple of more points about generative models. They're pretty straightforward. First of all, we've been doing the two-class case, right? You're either a skin or not skin. Well, suppose I've got a bunch of classes, C sub I, and I've got a measurement X. Which C should I choose? It's written here in green, C star. So very simply, I'm going to take the category that maximizes P of C given X. That is, which category is most likely given X? Okay, that makes some sense. Well, but I don't have that directly, so in order to do that, I use the likelihood times the, what's P of C? That's our prior. Okay, so I have to have my prior. So basically in generative models, as you add a new category, you just need to build a likelihood model and you need a prior model, and that'll allow you to compare one category to the next in deciding a new label. The other thing is, you remember before we were drawing these histograms to represent those probability distributions. Well, normally what you want is a nice continuous generative model. So what you need is a likelihood density. Okay, so you don't just have a histogram, you actually want a density. And remember, it's likelihood, so it's P of X given C, not P of C given X. That we get from Bayes' rule. All right? So typically, we represent those likelihoods using some parametric form. Here it's written as a mixture of Gaussians, right? So here, this particular class 2, you see it says P of X given C2, that's its likelihood. This is one little Gaussian lump. And we do that because we said, oh, that looks, you know, maybe most of the distribution of those pixel values is actually like that. But over here, for class 1, you see that we've got 2 humps. Okay? And that's just a mixture of Gaussians. And it's not too difficult to estimate a mixture of Gaussians from a modest amount of data. So one of the reasons to use these kinds of parameterized distributions is it allows you to use much less data in order to fit your density. So some of you might ask, well, wait a minute, why am I doing this whole continuous fitting? Why not just use some like k nearest neighbor or Parzon window method or something else that you learned in probability class? Megan's not going to remember that question, so I'm not going to ask her to remind. So why won't you do that? Well, you might do that. If you've got a lot of data, you might actually try to do some histogram KNN based method of estimating your density, but you would really need lots and lots of data sort of everywhere that you're likely to get a point, because you need the densities pretty much everywhere you're likely to get a data point. And in some sense, the whole point of generative models is to be able to use a modest amount of data. So the reason to use the parameterized thing is that you don't need a lot of data. Okay? And it allows you to generate a model that you can use for each category.